Hi, my name is Jennifer, and in this video, I'm going to show you how to multiply rational expressions. So grab a pencil and some paper and work through these examples with me. Let's take a look at our first example. We have 25x squared over 8x times 8x over 5x. Before we multiply, we're actually going to simplify first. We're going to make these into smaller numbers so it'll be easy to multiply. Now, just like multiplying regular fractions, we will multiply straight across, numerator to numerator, and denominator to denominator. But let's simplify first. Here's the rules of simplifying. If you have a term on either numerator, it can cancel with any term in the denominator, as long as it's a match. Okay? For example, and since all of these are monomials, they're not connected by a plus or subtraction sign, we're free to begin canceling. For example, 25 and 5, both of them are divisible by 5. So you can cross those out and put a 5 and a 1. Next, let's take a look at this 8 and 8. Both of those are divisible by 8, making that a 1 and a 1. And now we can continue with our x variables. Right here, so we can go either diagonal or up and down, or both. It doesn't matter. We have x squared, and it can cancel with this x, leaving an x, but this x would be completely gone. Over here, we have x over x, which that can cancel out. Okay, kind of looks like a mess. It's really important to keep up with what you have left. We have a 5 left over 1. We have a 5x left over 1. And then we have a 1 over 1. So now we're ready to multiply. We're going to multiply these two straight across. 5x times 1 is 5x. 1 times 1 is 1. So the final answer to this multiplication problem is 5x over 1, or just 5x. Okay, let's try this example together. We have x plus 7 over 3x squared minus 15 times x minus 5 over x squared minus 49. We are going to multiply straight across the top, straight across the bottom, except before we do, we need to simplify this expression. Now notice on this problem, all of them, the different parts, are binomials. When we can only cancel a binomial if the exact binomial is on the top or on the bottom. Okay? In this situation, if you quickly look, all of them appear to be very different, unique binomials. So what we need to do first is we're going to go to each of them and rewrite them by factoring them. So we're going to rewrite the problem, and we're going to attempt to rewrite as many of the numerators and denominators as possible. The first numerator, x plus 7, there's really no way to rewrite that. So we'll put x plus 7. Now let's take a look at 3x squared minus 15x. There's a common term in here, which is 3x. So we could rewrite the bottom 3x times x minus 5. Next, let's move on to the next fraction. The numerator is x minus 5, cannot rewrite that, so we'll put that back on the top. Take a look at the bottom. It's x squared minus 49. Do you recognize that? That's a difference of squares. So we can rewrite it as x plus 7 times x minus 7. Now if you take a look at your problem, you may see that you do have some matching binomials. So let's start canceling. We have an x plus 7 in the numerator, and it can cancel with an x plus 7 in either denominator. It doesn't matter which denominator. If you see on the far side, there's an x plus 7. So it can cancel, leaving us with a 1. Next, there's an x minus 5 in the numerator, and there's an x minus 5 in the denominator. So those two can cancel, leaving a 1. We have a 3x in the denominator, but we do not have any 3x in the numerator. We only have 1, so we cannot cancel this term. And we do not have another x minus 7 to cancel this one on the denominator. So let's see what we have left. We have a 1 over 3x times 1 on the bottom. Then we have a 1 over 1, and then we have the x minus 7. This is 1 over 3x, because 3x times 1 is 3x, times 1 over 1 times x minus 7 is x minus 7. So we'll write our final answer as 1 over 3x times x minus 7. And that's our final answer. Okay, let's do one more example together. Let's multiply 7y over 24 minus 6y times y minus 4. We are going to multiply straight across, but notice this side does not have a denominator. Anytime we have just a number that doesn't have a denominator, we can put that one over 1, just like we do with whole numbers. Next, we can only cancel binomials if they're exactly the same. Right now, these are not the same, and so we're going to go through the factoring process and see if that will help us be able to cancel. So let's rewrite our problem and see what we can factor. The numerator is 7y. There's nothing we can do with that, so we'll just bring 7y down. Take a look at this binomial, 24 minus 6y. Do you see that it's not in descending order? Do you see that the y term comes second and then the constant? So we definitely need to put this in descending order, but when we do, we would move this entire negative 6y to the front. And remember, we cannot have a negative leading coefficient, and so we're going to have to factor a negative 6 out. And we chose 6 because 24 is also divisible by 6. So if we factor the negative 6, and I'm going to put this in descending order at the same time. So I'm going to start right here. If we have negative 6y, if we factor out a negative 6, we're left with a positive y. Now I'm going to go to my 24. If I have 24, if I factor out a negative 6, I'm left with a negative 4. Because 24 divided by negative 6 is a negative 4. Over here, I have y minus 4. I could drop those parentheses off and just put y minus 4. And then, of course, I have my 1. Now that we've factored as much as we can, we're ready to simplify. Right here we have 7y, but notice that there's not another y that's free or a 7 for it to cancel. So we're going to have to just leave that one here. We can cancel y minus 4 with this y minus 4 because they're both binomials and they're both exactly the same. We do have this negative 6 on the bottom, but we do not have a number in the numerator for it to cancel, so it too has to stay. So we are left with our 7y times 1, and in the denominator our negative 6 times 1 times 1. If we were to multiply these red circles straight across, 7y times 1 is 7y over negative 6 times 1 times 1 is negative 6. Most likely you'll see your answer in the book is they'll take this negative 6 and put it straight out in front of this fraction bar. So your answer in the book may look something like that, where the negative sign is just out in front of the fraction, but either answer is correct. Now, if you have any other questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.